Yeah, good morning, bro. Today we'll see the second topic of Unit 3, the error surface for the linear neurons. Already we have studied the learning procedure for the linear neuron, learning weights of the linear neuron. Last class we have seen some toy example, if you are consuming meal every day in cafeteria, they are calculating the meal price. That is a linear neuron model. Then you understood the how the weight is calculated for the linear neuron. Now, error surface for a linear neuron. You know how to calculate the error for the linear neuron. The how to calculate the output for the linear neuron. First, understand the output of the linear neuron is calculated as yi equal to xi into wi. I is nothing but 1 to n. This is what we understood. And how the error is calculated for the linear neuron? E equal to desired output D minus current output Y. The difference between these two will give the error. What's that error surface? Yes. Every time we are calculating the meal price or any thing, any model, you are again and again you are calculating the values in iterative approach in linear model. Then you are getting the errors. Every time you are getting the errors. Then your ultimate aim is to reduce the error in order to bring to the actual. This is what the scenario. Every time the error is calculated, it is plotted in the graph with the help of x and y axis. Then the error surface lies in a space with a horizontal axis for each weight and one vertical axis for the given. So please understand how the error surface is plotted. Yes, error surface lies in a space with horizontal axis for weight and vertical axis for error. So by this, you can plot the error in a error surface. So horizontal axis, weight, this is x-axis weight. Then vertical axis, y-axis is error. So that is what uh, the diagram denotes. Okay, E, vertical. Then weight is horizontal. For linear neuron, we are calculating the error with a squared error measure. Okay. Then we are every time we are calculating with the help of squared error measure. Then you are plotting the errors in the error surface plot. Then you will get the shape as a quadratic curve. Okay, quadratic curve. It shows that at certain time the error is increased and slowly it is reduced. Initially you are assuming higher values, then error is high. Then gradually you are updating the weight and then slowly each iteration you are reducing the error. Then it goes to the exact output. Okay. While we are plotting the errors, then we are drawing the error line. It will show like a quadratic curve. This is what the linear neuron with a squared error. It is look like a quadratic curve. Understood? No? Good. Next, vertical cross sections. If you take a vertical cross section for the error surface, it looks like a parabola. You know the shape of a parabola. Okay, that is already denoted in the image. If you take the horizontal cross section, if you take the horizontal cross section, which looks like a ellipses. Yes, the error surface looks like a ellipses. This is to understand how the learning rate is uh, going. Every time you're calculating the error rate, then you're adjusting the weight, right? In linear neuron. After that, you are plotting each and every time you are plotting the error, then you can understand how the error goes. Either it is increasing or decreasing. So to understand the errors, you must plot the error surface. Then you can check the whether it's a quadratic bowl shape. If you uh, have a vertical cross-section of your error surface, it looks like a parabola. If you have a horizontal cross-section of your error surface, it looks like an ellipsis for the linear neuron. For multi-layer, non-linear net, the error surface much more complicated. So this is easily you can understand how the error is goes, and these are the different shapes you get while plotting the error surface. But this is only for the linear or a single layer perceptron. If it is a multi-layer perceptron, you have a more than one hidden layer. So this shape you cannot get easily in the multi-layer perceptron because non-linear nets, the error surface is much more complicated. So this is only for understanding the linear neuron single layers. Okay. Let's see if you're having a batch learning or a online learning, then how to understand the error? Yes. If you take a batch learning, the steepest descent on the error surface, it travels perpendicular to the contour lines. Like if you have a vertical cross section or a horizontal cross section, and it looks like a ellipsis. Okay, if it is a horizontal cross section, a parabolas. So if you take this diagram, you check here, you have a error points, then you are plotting the error points, then you are connecting those red lines, error lines. Okay, then this travels perpendicular to the contour lines. If it is a batch learning, okay, so that you can understand the error is linearly course. Okay, then you can come to the conclusion how to reduce the error. So ultimate aim is to reduce the error. Then you are having multiple error points. You have to plot the error points. Then only you can understand how to reduce the error, either by increasing or decreasing. So that understanding you need. That is why this error surface portion is very important. Okay. Then simplest kind of online learning. If you take online learning, let's take if you have two training cases. Okay, then you are having different error points for case one and case two. Okay, so if you draw the line by connecting all the error points, you will get the zigzag around the direction of the steepest descent because one line uh, goes perpendicular to the case 1 and one line goes to the perpendicular to the case 2. So it's looked like a zigzag there. Okay, if it is looked like a zigzag around the direction of steepest descent, it is an online learning. You have two different training cases. If you have two different training cases, the error surface looks like a zigzag points. Then using this plot, you can understand then which training case you need to reduce and which training case you need to increase, or like that you can get conclusion. Then you can minimize the error. So this is for linear neuron with only one case cases. Then you can plot the error. You can connect the line. You can easily understand it is traveling perpendicular to the contour lines. It is a simple batch learning. But here you have two different training cases. Then while we are plotting the error surface, it looks like a zigzag around the direction of steepest descent. One is perpendicular to the training case one, and another one is perpendicular to the training case two. Okay. Yeah. Now, why learning can be slow? So you are gradually increasing the error rate or decreasing the error rate in order to get the actual output. But this takes very, very slow. Why it is slow? Because if the ellipse is very elongated, the direction of steepest descent is almost perpendicular to the direction towards the minimum point. Okay, so already you know how to plot the error points, and you can connecting the error points. So if the ellipse is elongated, so every time you are plotting the error point, then you are having some conclusion, then you are adjusting the weight, again you are connecting the error point. While plotting, if the ellipse is very elongated, The direction of steepest descent is almost perpendicular to the direction of the minimum point. The red gradient vector has a large component along the short axis. Here, see here. The red gradient vector has a large component along the short axis, of ellipse, and a small component along the long axis of ellipse. This is this is just the opposite of the what we want. That is why the learning rate is very, very slow. Okay. That's all. That's all about today's class. So just recall what we learned. We learned the error surface for a linear neuron. You know what is error, then how to calculate the output you know, and how to calculate the error you know. But you must understand the error surface. What is the error surface? Yes, exactly. You are plotting, you are calculating error every iteration, and then you are plotting. Then you are coming to the conclusion whether to increase the error or decrease the error. So while plotting, if the error lies in a space with horizontal axis for each weight and one vertical axis for error, for a linear neuron, if it is look like a quadratic curve, vertical cross sections are parabolas, horizontal cross section are ellipses, but it is not applicable to the multi-layer person. Same kind, online versus batch learning. Okay, to understand the error surface of online learning in batch learning, this is batch learning, this is online. Okay. Then why the learning rate is very slow? That reason we understood. Okay, that's all about the today's class. We'll see in the next class with a different topic. Thank you.